Hello, my esteemed listener, my esteemed viewer. In this tutorial, we discuss very clearly about HTTP cookies, and this comes as a continuation of our explanation on application layer. In the preceding tutorial, as a recall memory, the HTTP and web were discussed. We recall a few important or significant points about HTTP. HTTP rides on TCP. Therefore, web-based applications are blessed with all reliability related matters which is provided by TCP to HTTP based applications. And HTTP is a pull protocol. It's called as a pull protocol because upon receiving a request, the HTTP server processes will find the requested information in its hard disk and will pull the same and send it with the response message, piggybacking the information that is sought by the client browser. HTTP does not maintain the state information of the users. Therefore, it is called as a stateless protocol. That is, it doesn't maintain the state information of users or clients. Even a user makes a repeated visit, to the server. The client browser visits repeatedly the server, requesting the same information intermittently. It goes unrecorded, and the server will never be able to recognize who was the user who came again and again with the same request. However, and this is the starting point of discussion on HTTP cookies. This feature of HTTP, the stateless protocol, the stateless nature of the HTTP has facilitated simplified server designs with high performance. That means this has permitted the servers to deal with thousands of TCP connections at any given instance because it doesn't maintain any state information of the requester or state informations of the various client processes. However, in certain situations, it is often desirable for a website to identify users, and there are two important reasons to do so. The first reason could be the server wishes to restrict the user access, or because it wants to serve the content to a user based as a function of the user's identity. In case of e-commerce related websites, particularly like Amazon or eBay, the users' buying habits, likes and dislikes are to be gathered by the websites. Therefore, for this sole purpose, HTTP uses cookies. That means cookies will establish indirectly the HTTP server and user interaction. It establishes the server and user interaction. The interaction goes like this. Mr. X wants to interact with the e-commerce site, say Amazon web server. His browser sends a HTTP request message. Being an e-commerce server, it creates an ID, a number here, an arbitrary example is given here. It creates an ID for the user and it gives an ID number to be 1890. This is being a e-commerce server. It is usual for a e-commerce server. It generates an ID number and stores the same in its backend server, and it sends the response message immediately with a set cookie header containing the ID generated just now, okay, upon receiving the request. Upon receiving the response message, Mr. X browser will store the cookies ID in its backend store. We can find over here the previous visit of this particular user, Mr. X, to eBay e-commerce site has already generated 2098 as its user ID. Of course, the entire process that is being rendered with the cookies can be explained with a timeline diagram. Let us walk through a timeline diagram to understand how cookies work. And it is understandable from the foregone discussion. Okay, the cookies has 4 components: a cookie header line in the HTTP response message, which comes first with the identity or ID number generated by the server, e-commerce server. A cookie header line in the HTTP request message. Okay, for the further request that is being made by Mr. X, the stored ID of a e-commerce site will be once again placed on the request message also. But this happens in the second request. Okay, when the second time Mr. X visits an e-commerce website or web server. A cookie file that is being kept on the user's end system and managed by the user's browser. This is the third component. And the fourth component being a backend database at the website. And we will just once again explain. Let us walk through a timeline diagram to understand how cookies work in detail. Mr. X accesses the e-commerce web, say Amazon, using Internet Explorer from his home PC or laptop, contacts Amazon for the first time. When the request comes into the Amazon web server, the server creates a unique ID. The Amazon web server then responds to Mr. X browser, including in the HTTP response a set cookie ID, which contains the identification number. Naturally, when X browser receives the HTTP response message, it looks at set cookie header. The browser places this line in the special cookie file that is available with the web browser and includes the server's name and ID number noted. Mr. X has previously visited eBay also, as it is revealed in this particular diagram. He has already visited eBay, let us say eBay website, and it has given him an identity number 2090. Mr. X continues to browse the Amazon site, let us say. Each time he requests a web page, his browser consults his cookie file, extracts his ID number given by the site, and puts this in the cookie header line. That is 1890 will be placed in the further request messages when he visits the e-commerce site for the second time. In this manner, the Amazon server or the e-commerce server, whatever it be, will be able to track Mr. X's activity, his buying interests, his buying habits, his likes and dislikes. It may not know his name, but it knows exactly which pages the Mr. X has visited, 1890 visited. Yeah, if Mr. X returns to Amazon site or the e-commerce site, say 1 week later, with a new request, his browser will continue to put the header line cookie, that is 1890, in the request message as it is seen over here. The e-commerce site may also recommend products and shopping cart service. If Mr. X provides all his credentials or details such as name, email ID, postal address, credit card information, Amazon can include this in its database, or any e-commerce site, as a matter of fact, can include all the details. Thus, cookies can create a user session on the top of the stateless HTTP by storing his information in the form of ID. However, there are few notable points on cookie. We see that cookies can be used to identify a user. The first time a user visits a site, the user can provide a user identification, possibly his or her name. During the subsequent sessions, the browser passes a cookie header to the server, thereby identifying the user to the server. Cookies can thus be used to create a user session layer on the top of stateless HTTP. Thus, a user server interaction is provided for the otherwise stateless protocol. For example, when a user logs into web-based email applications such as Rediffmail or Hotmail, the browser sends cookie information to the server, permitting the server to identify the user throughout the user session with the application. Anyway, cookies are found to be very controversial in certain situations. Because cookies are controversial because they can also be considered as encroaching the privacy of the user. It usually encroaches the privacy of the user. As we just saw from the foregone discussion, using a combination of cookies and user supplied account information, a website can learn a lot about a user and potentially sell this information to a third party. Often it is said, in the literature it is said, some of the cookies may bring in malicious software and impound on the user's browser's machine. Okay, with this we conclude a very important topic which brings in some kind of an interaction between HTTP, otherwise a stateless protocol, with the clients or client's browser. And with this we conclude, and in the next session we will talk about FTP, that is file transfer protocol.